I'm going to start explaining about the problem. So whey is normally obtained from cheese making, and up to 90% of the milk processed could be obtained as whey. So this is a big problem since, for example, in our country, 1 million liters per day are produced of whey, and this product is not normally used, is a waste and could be a contaminant. However, waste contains a lot of interesting compounds. Among these, we can explain about proteins, where 50% are lactoglobulin, 20% is lactalbumin, 10% is albumin, and these proteins have particular properties. That's why they are used as dietary supplement. Nevertheless, from these proteins, we can obtain bioactive peptides, and these are compounds that have normally from 2 to 20 amino acids, and these compounds can have an anti-hypertensive, antioxidant, antimicrobial, and immunomodulatory activities. But to have this activity, we have to release these peptides from the protein, because the activity is inside the protein. In these figures, we can see the examples of the bioactivity when a bioactive peptide is acting as antioxidant compound. This acts in the KEEP1 system, and then it induces the production of antioxidant enzymes. In this other example, the bioactive peptide can inhibit the angiotensin enzyme, which is responsible for this antihypertensive activity. When we want to obtain these bioactive peptides, different methods could be applied, and the pretreatments that we use in the protein could affect the activity of bioactives obtained. That is why in this work we are interested to evaluate the application of gamma irradiation and heat pretreatment, since these pretreatments can modify the structure of the protein. And when the structure is modified, the bonds of the proteins could be easily accessed by the enzyme, and it could help to obtain and release the bioactive peptides. To do this objective, we start by taking samples from cheese-producing industries. Then we treated this whey with microfiltration. We employed a ceramic membrane of 0.2 micrometers, and we treated at 4 bar and 30 degrees Celsius. This treatment was to eliminate principally the lipids that are in the whey. Then the permeate was collected in sterile recipients, and this permeate was characterized by the measure of the proteins, sugar, and fat content using the AOAC methods, and the soluble protein using Lowry methods. Then we treat this whey with different conditions. We employed a sample without any treatment as reference, and then we treat with heat and we sterilize the sample at 121 degrees Celsius for 15 minutes. And other samples were irradiated with a source of cobalt-60 with different dose. Then we performed the enzymatic hydrolysis for 9 hours, and we employed an experimental factor design, with the first factor being the pretreatment being the sterilization of the dose applied for gamma irradiation. And the second factor was the type of enzyme. We employed two enzymes, trypsin and a papain latex. As response variables, we measured the degree of hydrolysis and the antioxidant capacity. For the enzymatic hydrolysis, we employed the best conditions for each enzyme. For example, for trypsin, we employed pH 8 and 37 degrees Celsius. To maintain the pH, monobasic and dibasic phosphate salts were also added to the sample. And samples to measure the evolution of the hydrolysis was taken every 1 hour and a half. To calculate the quantity on enzyme to be added, we determined the activity of the enzyme employing the method described by Kopp-Enger and Ulrich, and we employed casein that substrate. The enzyme substrate ratio was fixed to 1/10, and this was fixed for trypsin, and to have the same conditions for papain, the quantity was calculated according to the results of the enzyme activity in order to have the same number of activity units in both experiments. The degree of hydrolysis was determined by OPA method, and we employed a microplate reader to measure the results. For the antioxidant activity, we employed two methods, ABTS and DPPH. In both cases, we used Trollocs as a standard, and the measures were also performed in the microplate reader. Here we can see the results of the microfiltration. We can see that permeate, that was the sample employed for the hydrolysis, has a similar concentration of protein as the feed, and in the retentate the concentration increased because some of the caseins are normally retained by the membrane. The protein calculated with the Yeldan method was slower, but this is probably due to the fact that in the Lowry method some compounds could interfere the measure. The sugars were almost the same in all the samples, and we can see that in the permeate the quantity of fat was reduced. So we took this permeate and we made the hydrolysis, and in this graph we can see the evolution of the degree of hydrolysis in the time. If we take the sample without any pretreatment, that is the sample M2, we can see that the degree of hydrolysis is the lowest. And for the samples M3 to M6 that were treated with gamma irradiation, the degree of hydrolysis increased, and this increment was proportional to the quantity of dose applied. For the sample sterilized M1, the degree of hydrolysis was the highest. This difference is explained by the fact that in the sample without pretreatment, proteins maintain their structure and their globular structure. So after the pretreatments, they normally change their structure, and this makes the bonds to be more easily accessed by the enzyme. This table summarizes the results obtained for both enzymes, trypsin and papain, and for the different pretreatments employed. We can see that the least degree of hydrolysis was for the sample without any pretreatment, and the highest values were obtained for the sterilized sample. The statistical analysis showed that there is a significant difference between the degree of hydrolysis with the use of the different pretreatments, but was not a significant difference between the enzymes employed. In these two graphs, we can see the evolution of the antioxidant capacity for the all the pretreatments. In similar way that for the degree of hydrolysis, we can see that for the sample without any pretreatment, the antioxidant capacity with both methods is lower, and it increased with the gamma irradiation dose, and is the highest for the sterilized sample. These trends are very similar to the trends observed for the degree of hydrolysis, and we perform an analysis of correlation between the two variables, and we found that both variables are correlated, and we have a correlation factor of 92%. This table summarizes the results for both enzymes, and with the different pretreatments with the two antioxidant methods analyzed. Similar to the results found before, we found that the pretreatment method has a statistical influence, and in this case also the enzyme had a statistical difference also. Finally, in this table, we can see the experiment performed in two different volume of reactions. The difference between the two volumes was the agitation. The first one was a rotary agitator, and the second was a magnetic stirrer. And the results have the same trends. However, for the biggest volume, the degree of hydrolysis and antioxidant capacity was lower. This shows that the conditions are very important to have the same results. Finally, with these results, we demonstrate that the sterilization and gamma irradiation could improve the hydrolysis of the whey proteins and could increase the antioxidant capacity of the peptides obtained. The pretreatment and the type of enzyme had a statistical significant influence on the degree of hydrolysis and the antioxidant capacity of the peptides. The sterilization was the best treatment that gamma irradiation. The science produces the highest values of degree of hydrolysis and antioxidant capacity. And we found also that there is a correlation between the degree of hydrolysis and the antioxidant capacity. I want to thank to the people who helped to the development of this work. And if you are interested to come to Ecuador, I also can invite you to come here, this Congress we are organizing. Thank you very much. If you have any questions.